last video we have shown that how to create the schematic for the inverter. So in this video I'm going to show you how to create the layout for the inverter. So go to the folder and open the terminal. Use the same commands which I have used earlier: csh, source home, and virtuoso ampersand. Wait for it to open. Okay, now it's open. Just first open the schematic which we have made earlier. Inverter underscore tb, or go to the inverter schematic, click on OK. Okay, this is the inverter schematic. Go to the launch and click on layout excel, create new. Okay, so at the library inverter, okay, click on OK session. Okay, now it's created the layout window. So go to the connectivity and click on generate all from sources. Minimum separation will be 1. Okay, so here you can see the poly selected, so change the layer to metal, or this will need to update poly to metal, update, or I have used this. Okay, everything is changed. Okay, just click on OK. So here everything is here, so we need to move this to here. Everything should be here, and just expand this. First zoom this out and click on S to expand it. Just expand this. It's enough, and same to the upwards. Okay, now move the pins. As you can see here, PMOS and NMOS is not showing, so just click on this PMOS and press the shift and F to see the inside view of the PMOS and NMOS. Select these PMOS and NMOS to move. Okay. Center, and for the pins, just click on place, pin placement, and as place in as a schematic. As you can see, everything is correct, and for the ground and VDD pin, we can expand complete to the top and bottom. For the ground, horizontal rail. Okay, and for the VDD, uh, we can use the horizontal rail. Okay, just close this. As you can see, the horizontal rail is created. Now we need to connect. Just create wiring, wire, and zoom this, so that wiring should be easy. You can directly wire, or we can use the well first and then wire. Select this and press Q to use the parameter, and here you can see body type is none. Let's detach, and for the PMOS it should be top tab, not left tab. Okay, one, and press OK. Okay, here is the body, so same should be done by this. Press Q and go to moment. Body type is detached, and at the bottom side of the NMOS, and click on apply. Okay, Okay, here's connected. Now create wire, create wiring, wire, connect the wire to the ground. Same. This is the source terminal of P NMOS, and this is the source terminal of PMOS. Okay, and source terminal are connected correctly. Now we need to connect the drain terminals. Okay, here is the drain terminal, and now connect the output. Okay, now everything is connected, just the input need to be connected. So for the input we need to first draw the polysilicon here. Okay, so to do the schematic we need to do some changes. Go to options, display, and here change the grid x snap to 0.01 and y snap to 0.01, and minor spacing will be 0.01, and pin name should be shown, and click on apply. Okay, now zoom. Okay, just click on create, go to shape, and there is the path. Okay, so this path should be connected to this. Okay, as you can see here is a VN, so it is connected properly. So just zoom out. Okay, click on escape, and here we need to use our wire to connect the metal to the uh, this input polysilicon. So go to create and wire, and here's a single wire, metal to poly. Okay, metal 1 to poly, create size. Okay, so here it is like this, so we need to rotate this for connection. So rotate this and click on hide. So here we need to connect this, click. Okay, just skip this and use the create shape and path. So give path from here to here. Okay, as you can see here is the input. So and now go to the create and wiring to connect the metal to the V input. Okay, just click on create, go to wiring and wire. Okay, metal 1 is connected. Go to create, click on wire, wire, just press P for the wire. Now connect this to this. Okay, now it's connected. Just escape this and click on F to view this. Okay, now save this. Now go to your Virtuoso to see if there is some error or not. Okay, now everything fine. Okay, now I have already saved this. Now go to the Asura to connect the technology and view. Go to the folder. Here select the uh, cadence and go to the foundry analog 90 nanometer, and here is the Sura Tech library. Click on OK, apply and OK. Go to the Asura and run DRC. Here you need to put the GPTK90 library. Click on apply and OK. OK, yes. Okay. Okay, now go to the run DRC and select the technology to GPTK90 and click on OK. Yes, yes. We just wait for it. Okay, now it's completed. Click on yes. Okay, no DRC found. Okay, our circuit layout is correct. DRC is design rule check, so our layout is completely fine. And now go to the LVS check. So here we need to select the in schematic versus layout. So everything is selected. Select the technology GPTK90 and click on apply. LVS already exists, no worries. Click on OK. Okay, just wait for it to complete. Okay, as you can see, there is no violations, and click on yes. Now here you can see the schematic and layout match. So our schematic and layout is completely matched. So it is done completely. So we can go to the Quantus setup to extract the schematic. Just go to the spice file extracted view, and other things are other things. We just cross this, go to the Sura, go to run Quantus, GPTK90. Okay, okay, great. Go to extraction. Here I need to extract RC values, and great. Okay, just click on OK. Let's wait for this to complete, as it will give you the extracted view of the layout with R and C values. Okay, AV is completed. So to see the AV, just minimize this and go to the Virtuoso, and here open, and here is the inverter and AV extracted view. Just open this. Okay, so as you can see, here is our extracted with resistance and capacitance, which you can find by zooming in. As you can see, here is the resistor, here is the capacitors, all the capacitors along with resistors. So everything is done completely. So that's all for this.